So hello, in this project, I developed machine learning classification model with a focus on the responsible AI principles and model interpretability. The main goal of this project was not only to build a model that performs well in predicting the target variable, but also to ensure that the model is fair, transparent, and also interpretable. So the first step of the project was data exploration and also pre-processing. We begin by loading the data sets and examining the distribution of the variables. So in particular, I explored several external risk um, indicators such as the external source 1 to 3. These variables are commonly known to be highly predictive in the credit risk related datasets. I visualized their distributions and also compared how they differed across the target classes in order to understand whether they provide useful signals for prediction, and this exploratory analysis helped me identify the patterns in the data and also guided later modeling decisions. So after understanding the dataset, I performed several processing steps to prepare the data for machine learning. First, I addressed some missing values. And for numerical variables, I use median input to replace the missing value. And for categorical one, I use it replaced with a categorical label name unknown. And also for the I also encoded the categorical variables so that they could be useful by machine learning an algorithm that requires numerical inputs. And one important design decision was that I kept the gender variable called gender in the dataset. This variable was not included primarily to improve the predictive performance, but rather to allow fairness adding later in the process. So in responsible AI workflows, identifying sensitive attributes such as the gender here is really important because it allows us to examine whether the model behaves differently across demographic groups. So after processing that, I moved to the model training. For this project, I selected a random forest classifier. Random forest is well suited for tabular datasets because it can capture nonlinear relationships and also the interactions between variables. In addition, it tends to perform well without requiring extensive feature engineering, which makes them a strong baseline for classification tasks. I trained the model using a training dataset and evaluated its performance on a validation set created using a train test split. This hold-out validation approach ensures that the model is evaluated on data that it has not seen during the train. So to evaluate the model's predictive performance, I calculated several standard classification metrics, including the accuracy, precision, recall, and also rock AC. So using multiple metrics here provide more comprehensive understanding for me. So let's look at the validation results. The model achieves an AUC rock score of about 0.63 and indicating the moderate predictive ability. And also the record for class 1 is relatively high at 0.59, meaning the model can identify many positive cases. However, the precision is low due to maybe class imbalance, showing the trade-off between detecting minority cases and also maintaining the prediction accuracy. So once the predictive model was established, I evaluated it from a responsible AI perspective. So responsible AI emphasizes principles such as fairness, transparency, and accountability. One key concern is whether the model produces systematically different outcomes for different demographic groups. So I evaluated fairness using two commonly used metrics, the demographic parity difference and also the equalized difference. So demographic parity measures whether different demographic groups receive positive predictions at similar rates, and while the equalized evaluates whether the model produces similar error rates across groups. So these metrics help identify whether the model may unintentionally favor or disadvantage some certain groups. So you can see the results from here. So this shows similar accuracy across gender groups with only small difference in selection rate. So a demographic parity difference and equalized difference are both around really small, like 0.4, and indicating relatively small disparities and suggesting that the model does not exhibit strong gender bias. And then in addition, I use metric frame to compute performance metrics separately for each group. So group level analysis is important because a model that appears accurate overall may still perform differently for specific groups. And next, I've focused on improving the model interpretability using explainable AI techniques. So to provide global explanations of the model, I use shape, so which measures the contribution for each of each feature to the model's prediction. Shape summarized plots help identify the most influential features and show how features values affect prediction outcomes. For local interpretability, I use Align, which explains individual prediction by approximately the complex model with a simple interpretable model around a specific data point. So I also use partial depends plots to visualize how changes in individual features influence the predicted outcomes. So together, shape line and partial dependency plots provide complementary forms of interpretability. The shape explains overall feature importance and the line explains individual prediction. So these techniques makes the model more transparent and helps the stakeholders maybe better understand how decisions. So after all, let's do the conclusion part. So from the ethical considerations, interpretability is important because it allows model decision to be audited and understood. So when machine learning models are used in real-world decision-making, transparency helps increase trust and allows potential bias to be detected. And the project demonstrates how machine learning can be developed while incorporating the responsible AI principles. So I just built a random forest classification model, evaluated its predictive performance, conducted fairness analysis using failure, and applied explainable AI techniques to improve the entire transparency and interpretability. So this approach helps ensure that machine learning systems are not only accurate, but also responsible and trustworthy. Thank you for